Welcome. We're going to be learning about limits using there goes the webcam. Using the laws to find limits and using algebraic skills also to find limits. There's a couple basic limit stuff up in this upper corner right here that you do need to know. They are very, very straightforward, and I'll explain them. So if you find the limit of a constant value, that's what k is. The answer is a constant, because again, a constant is like this kind of line right here. All right, straight line. So no matter what the limit is, it'll be the same no matter what. If you have just an x, you can just plug in that value right off the bat. Okay. Also, if we look at this function right here, if you're not familiar with what 1 over x looks like, kind of looks like this right here. Get some asymptotes in there. All right, and that'll kind of help you out. So from the left, it goes down to negative infinity. From the right, goes up to positive infinity. That's some important stuff to know. This right here is really our meat and potatoes for the laws part of it. So for the limit laws, know these things, and they are relatively straightforward. So if you have a limit that goes to one function, or one function is equal to that, one, you have a different function. Well, if you add the two functions together, you can just add the two limits together. Again, these are two functions that have limits. You can subtract them, and you can just subtract the limits. You can multiply them, just multiply the limits. You can divide them. Again, there could be a restriction, though. That bottom one can't be a 0. If it is, then there's a little more work to be done, such as, well, we'll kind of get to that when we get down here, the 0 being the denominator. And then square rooting, you can just square root the limit, provided that n is even. Well, n is even, so it's square rooting, fourth rooting, sixth rooting, whatever. Okay. So anytime we're asked to use the laws, we actually have to show every single little step with the laws. So to find this limit right here, if I'm not asked to use the laws, you can literally just plug in the number and then be good to go. But this asks to use the laws, so I'm going to split this up into the limit as x approaches 5 of x squared minus the limit as x approaches 5 of 4x plus the limit as x approaches 5 of 3. Okay? So from here, you can just plug 5 right in. 5 squared, 25, minus, plug 5 right in, 20, plus, plug 5, it's constant, don't need to plug anything in. It's just going to be a big old 3. So 25 minus 20 plus 3 is snowman, 8. And that's how you use limit laws. Just make sure when it says use limit laws, you actually show those, show the work. Even if it says show all work, same thing. You have to show the work for the limit laws. Hey, what if this ever happens? The limit, the denominator is 0, and the top is not. For example, if you have like the limit of x approaches, just say a of a function, and you just get some number on top over 0, then this is what we're talking about. The limit is either going to be negative infinity and positive infinity, or it might be negative infinity on one side and positive infinity from the other side, which would mean that in this scenario, this is a does not exist. So I'll go over one of those problems on the back for what that may or may not look like. All right. Okay. So algebraically, the first thing you do to find these limits is you plug in the number until you get an uh-oh. Okay, so there's really two types of uh-ohs. First uh-oh is something called this indeterminate form, which is 0 over 0. That means you need to keep going. By that, I mean do algebra. So like factoring or combining fractions or doing fun stuff with radicals, plugging in, distributing, simplifying, whatever. That's what that keep going means. There's lots of different things you can do. So for this first example right here, when I plug in a 2, I'm going to get 2 squared, which is 4, minus 4, which is 0 on the top, and 2 minus 2 on the bottom, which is another 0. So I'm going to get 0 over 0. If you remember back from pre-calculus, that represents a hole. So that's just a hole. So we need to do something to rewrite this function so that I can plug a 2 in and it will work. Okay. So first thing here, as I would just factor it. Okay. Anytime you do limit work, by the way, you actually have to write down that limit notation every single step until we actually plug in that 2. So factoring the top, we're going to get x plus 2, x minus 2, all over x minus 2. Something cancels out here. And whoop, that gone. So I'm left with just the x plus 2. So the limit x approaches 2 of x plus 2. You notice I keep writing limit because, well, I'm not lazy and I'm following correct mathematical procedure. Now I'm ready to plug in the 2, so I can just do 2 plus 2, which is 4. All right. Next example. I'm going to plug in a 1, and I'm going to get 0 over 0. If you notice, I don't write equals 0 over 0 because, well, it doesn't actually equal that. If you write equals, you're going to have a bad time. It's not going to be correct. So, best thing to do here, whenever you have a radical, I don't care if the radical's on the top. I don't care if it's on the bottom. It's going to be the same thing each way. You're going to multiply the top and bottom by the conjugate. Conjugate means that the terms, the middle term, that little sign right there, just changes. So if it's a minus, turns to a plus. So multiply the bottom by x plus 1, root x plus 1, I mean, top by root x plus 1. Okay, so now when I do that, whatever side does not have the radical, in this case it's the top, don't simplify. Please don't distribute, because we multiply by the conjugate on purpose so something will cancel. And now since it's the conjugate, it's oh so convenient that root x times root x is x. The middle term's going to cancel out. It's a conjugate. -1 times +1 is -1. Now, hopefully you see it, and you're super glad that you did not distribute the top, because something cancels out. What cancels out? The x minus 1s. See you later. So you're going to get the limit as x approaches 1 of root x plus 1. And now you are ready to plug in the 1. So you're going to get root 1 plus 1, which is 2. And I will box up my answers. And that's pretty much the fast way and quick way of explaining algebraic limits. There are more situations, but as you encounter them, you'll just have to figure something out to take care of them. Now, there's also piecewise functions and how to do limits with those. What you can do for piecewise is just look at this example right here. By the way, what piecewise means is when a function has multiple pieces. So we find the limit of this. In order to find the limit at -2, I have to do the right and the left just to see if they match. Okay? So let's go ahead and do this one. So let's find the limit as x approaches -2. So I'm going to go off to the side. Now there are two ways. It does say this. It's to do it algebraically, which is the first one. The bottom one is to graph. I'm just going to do the algebraic way. If you want to graph it, it'll be on the keynotes. You can just try that yourself. So I'm going to do the limit as x approaches -2. I'll do this from the left first of this function. So since I'm doing it from the left, now look at this. I have two -2's. Which one's the left? Which one's the left? Top one right there is going to be the left, okay? So I'm going to do the limit. X approaches -2 from the left. I'm just going to write this as 1 over x plus 2, just so it's super clear what we're doing here. Directly plug it in. It's the first thing you do. In this case, you're going to get a 1 over 0. It's not 0 over 0. This one's not a hole. So it kind of comes back to where we were on the front of this, the bottom right here. All right, if the denominator is 0, we got to do something special. So it's time for that special time. Here we go. So I have to figure out if this is going to be going to positive infinity or negative infinity, since it's one-sided. Okay. If it was not one-sided, you would need to do the right and the left. But since it's piecewise, I'm just doing the one side. So what I'm going to do is I'm going to pick out a value that's like super close to -2 and from the left. So I'm going to use -2.1. I'm going to plug that into my function. So I'm going to get 1 over -2.1 plus 2. Now, I only care about signs, positives and negatives, because again, I'm going to an infinity, whether it's positive or negative. I only care about the signs. So the top is 1, which is positive. The bottom, the reason it's nice to do just the signs, because in case you're not so great in mental math, kind of saves you, right? If you're like, oh, I don't know, but I know it's negative. Well, it is indeed negative. So you're going to get a positive divided by a negative, which is a negative value. So this is going to equal negative infinity. Okay. So that's for -2 from the left. Now I have to do the right side. And if you look on our handy-dandy piecewise function here, it's going to be this middle guy right here. So this is going to be the limit as x, I don't know what I just did right there, x approaches -2 from the right of x squared minus 5. Nothing fancy going on here. You can actually just plug in right off the bat and you'll get a nice answer. You don't need to use the limit laws because it doesn't ask you specifically to show how it works. So you're good just plugging this in. So you can do -2 squared minus 5, which is -1. So here's the left value, negative infinity. Here's the right value. Are they the same? Hopefully you said no. So what does it tell me about this? Since they're not the same, well, this does not exist. And that will wrap it up for limit laws and using a little bit of algebra with limits.